Bismillahirrahmanirrahim. This question is from May June 24, variant 23. Question number 1, topic measurement uncertainty. Drag force FD acting on a sphere falling through a liquid is given by this formula. FD is equal to 6 pi eta r, where r is in radius, v is the speed, and eta is the property of liquid. Show that SI base unit of viscosity is kilogram per meter per second. Okay, so to find out the base unit of the viscosity, let me make a viscosity as a subject. So equation FD will be equal to 6 pi eta RV. This is the real equation. I have to make eta as subject. So eta will be equal to FD divided by 6 pi r into v. So I know well that the unit of the radius is meter, the unit of the velocity is meter per second, and viscosity unit I have to find out. And one other thing, that is the drag force. So force always have a unit Newton, and that Newton will be equal to kilogram meter per second square. Okay, so to find out the units for the eta, I have to put the units of all other quantities. So force is kilogram meter per second square. 6 pi constant, no need to write a unit, ignore them. R unit is meter and velocity unit is meters per second. So here is some mathematics. Kilogram will remain as it is, m power 1. So this m and this m from the bottom, from the denominator in having power 2, when it will be shifted as a numerator, it will be power minus 2. S power minus 2 already mentioned here. So when s power minus 1 shifted as a numerator, it becomes plus 1. So final answer, eta have a final unit kilogram, m power minus 1, s power minus 1. So this answer is exactly matched with the answer given by the examiner to show. So both answers are same. Now the second part of the question, B part of this question, the sphere has a radius 3 centimeter, mean 3 into 10 raised to power minus 2 meter, vertically downward falling, vertically downward at terminal velocity. Okay, so for the terminal velocity, net force 0, acceleration 0, acceleration 0 meters per second square, and F net will also be equal to 0 newtons. Terminal velocity of 2 meters per second through a fluid, the drag force acting on the sphere. Okay, so drag force is also given 0.096. Calculate the viscosity of the liquid. To find out the viscosity, I will use the same formula. This one. So formula says that eta will be equal to FD 6 pi r into v. So drag force is given in the question 0.096. It's given 6 as it is, pi value 3.14, radius value 3 into 10 raised to power minus 2, and the last value is the velocity that is given in the question, multiply by 2. And then after calculation, so calculator gives me the answer of viscosity 0.085. C part of this question says that the sphere is shown in figure 1.1. On the figure 1.1, draw and label arrows to represent the direction of the three forces acting on the sphere as it fall with the terminal velocity. So we know well, when any object is falling down either in a water or a liquid, then a drag always act opposite. So this object is falling down because of its weight, and drag force because of its downward motion is always up. So I will write drag force as Fd, as well as water will exert a force, that is upthrust force. So there is another force that is named as upthrust. Its direction is also upward. So D part says the density of the liquid. The density of the liquid is 920 kilogram per meter square. Show that the upthrust acting on the sphere is equal to 1 Newton. We know that upthrust is always equal to upthrust will be equal to, according to Archimedes principle, rho, G, and V. Okay, so value of rho is given, that is 920, value of G is 9.8, but as a sphere, its volume will be 4 pi 3 pi r cube. So let me calculate this value. 4 by 3, as it is constant, pi is equal to 3.14, and r is the radius of the sphere. That is given, I think, in the previous part of the question. Yes, it is given 3 into raised to power minus 2. So 3 into 10 raised to power minus 2 and its cube. If I put the value of the volume here, then the combined calculation will be equal to 1.02 Newton, that is rounded off as 1 Newton. Calculate the mass of the sphere. Okay, see, from this diagram, we can see that weight and these two forces are equatable. Weight is downward and these two forces are upward. To find out the mass of the body, I will use that equation, that weight of the body will be equal to the drag force plus upthrust force. Okay, so weight will be equal to mass multiplied by gravity. Drag is given in the question, that is 0.096, and upthrust we just have calculated, that is 0.01. This is the upthrust force. So I will write as 1, and I know mass is unknown, value of G is 9.81. So 0.096 plus 1, rearrange these values, then mass value will be 0.11 kilogram. So unit is already given. This question is for 10 marks.